A month ago, rapper b.o.b and astrophysicist Neil deGrasse Tyson got into a Twitter argument over his beliefs that the Earth is flat. Many people on Twitter responded by saying that b.o.b had medieval thinking and he was stuck in the 13th century. But did educated people in the medieval times actually believe that the Earth was flat? This is actually a myth that was started sometime in the late 19th century. Medieval scholars actually accepted that the Earth was spherical because this fact had been established by Greek philosophers many centuries ago. Plato had taught his pupils that the Earth was a round body in the center of the heavens, but he provided no evidence for it. It was his student Aristotle who recorded the following observations. The shadow of Earth on the moon during a lunar eclipse is round. When you go south, southern constellations start appearing over the horizon and rise higher into the sky. Not only that, but another observation that you can make is that the bottom of a ship disappears first when going over the horizon. All these facts are simple observations that can be made by anyone with a keen eye. Because ancient Greek philosophers knew about a spherical Earth for so long, it was an accepted fact in medieval Europe among scholars. But the Greeks didn't stop there. One Greek mathematician went further and calculated the circumference of the Earth. His name was Eratosthenes of Cyrene, and his value was off by only 10% from the value we have today. 10%. And all it took was two guys in the desert with sticks. Before we discuss how he calculated this, we need to know the assumptions he made before proceeding. The first assumption was that the Earth is a perfect sphere. The Earth is slightly wider at the equator because it's rotating, and so we use an average figure for the circumference of the Earth. Assumption 2. Two cities, Alexandria and Syene, lie on the same meridian. We will get to the significance of these cities in a minute, but what this means is that they lie on a straight line connecting them to the poles. These lines are known as meridians, and are an example of a great circle. A great circle is a term used in geometry for the largest circle that can be made on the surface of a sphere. The center of a great circle is always the center of the sphere, and the radius of a great circle is the radius of the sphere. The equator is an example of a great circle, and so are the meridians. But great circles aren't just these latitudinal and longitudinal lines on a map. They can exist in any orientation you like. Ever got so bored on a long flight that you decided to look at the live app to see what path you're taking to reach your destination? You would have noticed that the path looks curved. Hang on a minute, you think to yourself. Why is this airline wasting my time and wasting this fuel by taking a long way around? Why can't they just go straight there? This is because they actually are taking the shortest possible route by following a great circle. See how this line obviously looks like it's the shortest line from one point to another on this circle? Well, when you display this line on a flat plane, like our maps, they appear to be curved. This just shows that it isn't possible to accurately map a sphere onto a flat plane. Assumption 3. The distance from Alexandria to Syene is 5,000 stads. A stad is an ancient unit of distance that is about 176.4 meters. His estimate would be a distance of 882,000 meters from Alexandria to Syene, when the real answer is 842,000 meters. It was less than 5% off the true value. Assumption 4. The Sun is so far away that the rays of sunlight reaching us are effectively parallel to one another. So now, let's get to how he did it. Eratosthenes had heard that at noon on the summer solstice, the sun is directly overhead the city of Syene. This can easily be checked by putting a stick vertical in the desert. If it makes no shadow, this means that the sun is directly overhead. He then proceeded to do the same at Alexandria, at midday on a summer solstice. By measuring the shadow made by a sundial at that point, he could compare the two pieces of data to work out the angle made by the sun from the vertical at Alexandria. This diagram shows that this angle will be the same as the angle between Syene, the center of the Earth, and Alexandria. The angle he measured was 1/50th of a circle, which is 7.2 degrees. If you know the distance of the arc between Alexandria and Syene, which he assumed was 5,000 stads, all you have to do now is multiply this distance by 50 and you have an estimate for the circumference of the Earth. His estimate was 44,100 kilometers, and our modern accepted value is 40,075 kilometers. He was only 10% off, which is remarkable for the tools he had and the science of his day. In the end, you're actually insulting the medieval thinkers by comparing b.o.b to them. Instead, say that his thinking is more in line with the observations a caveman would make. Now, that would be a more accurate representation. Today, we learned that medieval scholars believing in a flat earth was just a myth. The Greeks had not only shown that the earth was spherical, they had also calculated the circumference. We also learned a bit about geometry and great circles, as well as empirical evidence for a spherical earth that you can observe with your own two eyes. It really is surprising how these societies can exist in this day and age. Thanks for watching and subscribe for more.